Hey there! In this lecture, we're going to talk about Pandas, which, just like NumPy, is another framework which is used by data scientists all across the globe to deal with data sets which are mostly and stored in Excel files and tables. And you can say we are dealing with, whenever data scientists are dealing with tabular data, they use Pandas framework to access that data and perform functions on the data, prepare the data, and stuff like that. So let's talk about Pandas a bit more. So in order to import the pandas package, we use import pandas as PD, and just like before, PD is the alias and the traditional convention used by all data scientists, and it has some semantic meaning to the pandas as well. So you can use this alias, and just on the record, you can use any other alias if you want. So just like NumPy, Pandas gives us another access to another data structure which we call data frames. This is a two-dimensional data structure which consists of rows and columns, and it can store tabular data of different types like int, character, or string. It is similar to a spreadsheet or a SQL table if you're familiar with that, but in simpler terms, it's just easy to remember that it has rows and columns and mostly used to represent tabular data. Like NumPy, it provides us with the data structure. Like in NumPy, we had these NumPy arrays, which enabled us to store data in the form of arrays. Now the question over here is that we can use NumPy to store 2D data as well, which can be represented in the tabular form. So why do we need data frames? So the thing is that Pandas library in the backend uses NumPy to actually build these data frames are actually NumPy arrays. We call them the NumPy ND arrays, and these are actually 2D NumPy arrays in the backend. So a data frame in actuality is just a 2D NumPy array, but in this way it gives us another interface, another layer of abstraction to make things easier for us, because we have seen before that it's difficult to deal with 2D arrays when it comes to slicing, indexing, and accessing these arrays. So in order to ease all those things up and to easily perform operations on these 2D arrays, we have introduced another data structure provided us by Pandas, which makes it easy for us to do all of that. So let's look at the syntax of creating a Pandas data frame. So the Pandas data frame is created by using the following syntax. Over here you can see that we have the name, age, and sex, which are represented by double quotes, and they're followed by colon and square brackets, which has information of it. Okay, if you considering the concept of this code, it is pretty simple that the values that mentioned in the square brackets belong to the names, belong to the words, or you can say attributes on the left side of the column. So over here they are represented as columns of the data frame. So we have provided these columns with information, and whenever we want to print this df, we will see that each column shows the information we have stored in it, and we have 3 rows considering the amount of information we have for each of them. So in this case we have equal information for all the columns. So what would happen if I had only one name and 3 values for age and 2 values for sex? So how would the data frame deal that? Would it be an error, or would it provide an alternative solution to it? So we'll see that shortly in a couple of minutes. We have shown that each column has equal information, so there is no values. So but the question over here, which maybe we'll come across this example again and you will see, maybe we'll have some of these examples, but I would suggest you should try it whenever you're creating a data frame. It's fun and you should try it out to explore more, that leave, or you can say have an uneven information in the data set, and then see what happens. So let's talk about accessing columns. Just like in NumPy arrays we had indexing, over here we are going to use the same concept. In order to access columns, we're going to access them by their name, and there are 2 ways you can do that. Either you can have square brackets in which you can have the name in double quotes, or you can access the name by using the dot format. Both of these attributes tell us one thing, that you're accessing the column age and you're accessing the information in it, and it will print out the information of that column. So there is another data structure which resides within the data frame. It is called the series, and it comes after the NumPy arrays, and then after series we have a data frame. So you can say that series creates a data frame. So we can say that each column in a data frame is a series. So this is similar to the NumPy array, and we have these series can be represented into columns, and they have sequence of information in them, and they can be represented by this particular syntax. We're going to use pandas to create series, and these series will ultimately be used to create data frames. But for the time being, let's just focus on this particular format and this structure, this, you can say, the tool, the extended operation which pandas gives us. And we're going to see that how we can apply operations on series as well as data frames. So as far as the operations are concerned, like in NumPy arrays, we saw that universal functions were used. In this, we're going to use the same concept, and we're going to understand that all operations that are applicable on a data frame are also applicable on a series. A data frame column, since is equal to a series, that's why they both can have the same number of same type of operations. So considering the operation of max, if you want to find out the max age in the particular column of a data set, we're going to use the df age dot max, and you can access age in both of these ways, and both of them will give you the same value. So the main function and why pandas was actually created, and how it is being mostly and widely being used, is that we need to access different types and different formats of data, which are mostly represented in the form of tabular data. So there are many formats of representing tabular data. We have XLS, CSV, JSON, and all of these, the SQL spreadsheets, all of these are tables, and we needed to process these tables in Python. So in order for us to be able to successfully process them, we needed to convert them into our favorable format. We needed to have a data structure in Python which can store this information of different formats, and so that we can also apply operations on them. So after we're done with processing this information on this data frame, we have to convert this information back into its original format. So there are two types of functions pandas provides us: the reading function and the to function. So the read function enables us to read the tabular data coming from any format, and the to function enables us to write that tabular data back into the same particular format or any other tabular format. So that is one of the most powerful functionalities pandas provides us. So let's look at the code. Mostly datasets, and across this course as well, the datasets we will be dealing with will be in CSV format. So we will be reading CSV files which will have many different columns, which will have many different rows. You can say that it will be a dataset, and we will understand the concept of a dataset when we will study machine learning. For now, a dataset is something that has columns and rows. So it is a 2D matrix, or you can call it as a table, which has a lot of information, and each row is independent of the other row, and each column represents an attribute of that particular row. So considering this particular example, we will read the California housing dataset, which is quite popular dataset for beginning machine learning problems. And after reading it, we will display it using the df, and we have seen that it has about 9 attributes of the dataset, and we're not so sure about the rows, how many rows, which actually represent the size of the data. So we'll see that shortly. So the thing is that this is the read CSV function. We're going to read the CSV files, which are actually the datasets, and we're going to store them in a data frame using the pd.read CSV function. So the other function that enables the data scientist to explore the dataset, it is the head function. So df.thehead, and remember that df is the data frame in which we have read the CSV file and stored the information in a data frame. So now we're going to access this information using the df.head, which tells us that you can explore the values so that you can get an intuitive feel of the dataset. You can understand it by looking at it, and after some time, when you have gained enough experience, even this small function can tell you a lot about our dataset. So you will see that, okay, you're sure now the number of columns, and you can see, okay, these are the columns. Does the dataset look right? So these are the stuff that is quite insightful whenever we're studying a dataset. So df.head and square bracket information tells us about how many rows do you want to display. And if you do not put any other value in it, by default, it will always show the first 5 rows of a data frame. Okay, so df.head, the first 5 rows, you have accessed and explored the first 5 rows. You have seen that this dataset looks right. There are a number of columns. This doesn't seem out of the blue, and nothing seems to be out of the ordinary, and you can proceed with it. Just like the head function, we have the tail function. The tail function exhibits the same functionality in terms of displaying the number of rows, but the difference is that now we can access the last 5 rows of the dataset, or any last number of rows you want to display. So head function can access and display the starting of the data frame, and the tail function can display and access the ending of the data frame rows. So the other function of data frame which enables us to visualize the columns to see how many columns are there. We have the df.columns. And now the question is, why do you need the columns if you can actually see them using the df.head? Because they're quite visible there. The thing is, sometimes the column space, or you can say the feature space in a more machine learning terminology, is quite big, and it exceeds the display format of you can say the Jupyter notebook or a collaboratory notebook. So you're not able to fully visualize and read the columns there are by using the df.head function. For that particular purpose, Pandas gives us another option. If you want to display the columns in the form of you can say a series, and then read them or maybe display them, then you can have the df.columns, which tells us that. So the other functionality, which is quite important in terms of exploration, and then we will study about EDA, exploratory data analysis, you will see that all of these functionalities have very huge and impactful essence to the whole data science genre. So it's very important to understand them and to see them why, because later on we will see that why they are important. For now, let's just see what, and then later on we can study why. So df.datatypes tells you the data types of all the columns you have seen. And now you just found out the different data types there are of all the columns. So let's talk about pre-processing the data frame which you have just read through the CSV file. And let's talk about creating a new column. This particular feature of Pandas is used quite repetitively in feature engineering. Whenever you're engineering the features, you have to study them and conduct a couple of experiments, and then you find out that I can introduce a new feature in this dataset which is quite useful and will have a high correlation with the target variable. So it's this feature needs to be engineered right away. So the create new column of Pandas gives us that the ability to add another feature after conducting thorough experiments into the dataset. So just like I said, it is important in feature engineering, and we have renaming a column and derived from existing column. So this thing is, whenever we introduce a new column, we're talking about another feature of the dataset. So most of the time it is derived from the existing columns or the existing features of a dataset. We'll see that when we will study more of it in EDA, but for now let's just remember the concept, and let's see that the beauty of Pandas is that it gives us these options. And you can say that the Pandas was created because we needed such powerful tools to enable us to do everything so well and in a better way. Let's see an example of feature engineering so that we can understand the application of how, when we say that we can derive another feature from the existing features, how do we do that? So let's look at the feature called total rooms in this particular dataset and the feature called total bedrooms. So we know that this is the dataset of the housing prices of California houses, and we have two features over here, the total rooms and total bedrooms. Now we need to find that how many bedrooms are there per room. So we know the total number of bedrooms and we know the total number of rooms. So we need to find out how many bedrooms there are per room. So we can do that by dividing the total number of rooms by total bedrooms. And we will introduce another feature using this particular syntax, and this is where the feature will be introduced. And after that you will have, you can say, overwritten the existing data frame, or you can just say simply that you've just added another feature using the simple syntax, using the existing features. You can do that without using the existing features, but it has to make sense. So there has to be some logic, there has to be some intuitive understanding and logical explanation, which has some scientific roots to the problem, because existing features do have high importance in the dataset. So it's always smart to drive new features from them. Okay, so far we have seen the function of adding another column, which is used in feature engineering, and now we're going to read about the renaming of columns. For the purpose for this is particularly to make the features, the names of the features, into more appropriate names. Since before we saw that the names were total bedrooms and total rooms, so in order, if we wanted to change these names into bedrooms and rooms, which made more sense, and it made it easy to visualize them, so it is another useful function which Pandas allows us to do that.